So, welcome listeners. Again, we have gathered here to discuss on the next topic, that is your sedimentary rocks. After our discussion on rocks, rock cycle, and igneous rock, in the series of lectures on fundamentals of geology. So, here we will be discussing on the again in a few parts. So, in the first part, I'd like to discuss about how a sedimentary rock is formed. But before I start that, if you can remember our discussion on rock cycle, that we have seen that though volume wise sedimentary rock only is having 5% of the total volume of the earth crust, but if I look at the surface area covered by sedimentary rock, then it is almost about 75% of the earth's surface is covered by sedimentary rocks. So that's why wherever you go, you can say that you have a chance of around 70% or 75% chance are having surrounded by some kind of sedimentary rocks. So we'll again looking at the rock cycle, if you can remember here, we'll mainly discuss about this part of the rock cycle, that is sedimentary rock, and the processes that are related for the mainly for the formation of the sedimentary rock, be it the evolution of a sedimentary rock from an igneous rock, from a metamorphic rock, or from an earlier existing sedimentary rock. So obviously we all know that apart from igneous and metamorphic rock, there is sedimentary rock that are present, and they are in simpler terms I can say that they are formed as a result of your weathering of sediment from certain rock. They followed by the erosional processes, followed by transportation, and then deposition of that sediment or accumulation of that sediment, and finally also some due to some lithification processes. We'll look into these processes individually from some pre-existing rocks with the help of even sometimes some organic matter and chemical precipitates. Finally the transformation or the final formation of a sedimentary rock takes place. Some structures that are exhibited by sedimentary rocks, which are generally again referred to as primary structure, like bedding, some ripple mark, graded bedding, these will be also discussed in greater detail in the later part of this discussion on your sedimentary rocks. Also remember, sedimentary rocks are the rocks where you will be able to find, or you will target sedimentary rocks if you want to target fossils. So again, sedimentary rock are extremely important for targeting fossil or organic remains. If you are working, or if you want to for example you are researching in a field where you want to find the time of formation of a particular fossil, then the target that you should have, that you have to find some sedimentary rock first which will contain that particular fossil. So then only you will be able to do your rest of the research on that particular fossil. But first you have to target those rocks specifically which will contain the targeted fossil you are looking for. And also it is classified on the base of its composition, texture, and mode of formation, like we have seen also in case of igneous rock. So any rock, be it igneous, sedimentary, or metamorphic, they need to be classified as well based on its composition and texture, and also where they might occur on the earth. Now the importance of studying sedimentary rocks, again if I say, they preserve a detailed record of the past environment, climate, and geological events. And sedimentary rocks provide valuable insight into major geological events such as mass extinction, like just I was giving an example that if you want to target an event of mass extinction at a particular time in the geologic past, then you look for sedimentary rock that should have some fossils that got extinct at that particular time period. Or also it contains evidences of climatic shifts. For example, they are have been reports of based on sedimentary rock or studying sedimentary rocks. There have been reports of marine transgression and marine regressions, and they are also based on the detailed study of your, for example, limestone, which is also chemically derived sedimentary rock, which are also referred to as non-clastic sedimentary rock. We will be discussing about that as well. Then coming into other importance of studying sedimentary rocks, like resource exploration and management. Most of the power source across the world, or be it in India as well, you have or we are dependent on energy resources. Till now we are still dependent on energy resources like coal and petroleum. So sedimentary rocks are the sites of this exploration, or where you will get your coal and petroleum, because sedimentary rocks like coal are result of nothing but process, again by the processes that are related to sedimentary rocks, like the process of diagenesis and lithification. Finally a sedimentary rock is forming. If that sediment during or prior to the formation or prior to the lithification process, if it contains plant remains, then it will result into the formation of coal seam that are also associated with the rock, for example sandstone. Again, to target coal, you have to also understand the overlying or underlying sandstone layers within which a coal layer or set of coal layers are embedded. Similarly, in case of petroleum as well, you can also look at this example, a simple schematic diagram where you have this impermeable shale clay layers and some porous reservoir rock where your petroleum will be trapped within that. So you have a means you need to have a porous sedimentary rock which will trap the, finally again petroleum are derived from nothing but the animal remains of some time. So they are now, or they have been modified into petroleum, also natural gas. So in that case, this your oil or natural gas will be trapped in some porous sedimentary rock, but they need to be capped, or they need to be, you can say, surrounded by some impermeable other sedimentary rock, so that the oil and gas doesn't simply leave the reservoir. So you, for the formation of traps where you will target for the exploration of petroleum or natural gas, you need to also understand that how a sedimentary system works. Also, they provide valuable proxies for past climate conditions, including isotopic signatures. Sedimentary structures, again like I was saying, that sedimentary structures are always primary in nature, and also your fossil assemblages. So your different fossil assemblages might be present in a particular sedimentary rock. From that you can, if you know the age of the fossil, or somehow if you can, based on dating, some method of dating, you can date the sedimentary sequence as well. You can also have an idea of the age of the fossil, and vice versa obviously. So based on that you can also determine the it means you can say some large scale mass extinction event, or some other geological events of, for example, marine transgression, marine regressions. And also sedimentary rocks are being studied regularly based on the idea that if you are constructing some bridges or some tunnels or some other a large scale structure during infrastructure development of some kind, then you need to rely on the foundation rock. And like I was mentioning, again, as based on surface area, sedimentary rock almost covers about 75% of the earth's surface. You can say that you need to identify, or at least analyze, a sedimentary rock first to finalize your foundation rock on which your rest of the foundation of a bridge, for example, will be built upon. So based on that, you need to have a detailed idea of how your sedimentary rocks are formed, as well as what are the different kinds of sedimentary rocks, and later on we will also looking at the different sedimentary structures. So first, with the formation of the sedimentary rocks, we will start with the processes. Again, we will take a cue from the rock cycle, where we discussed a little bit about weathering. So Weathering should be followed by erosion, transportation, deposition, and final lithification. So, weathering is nothing but the breakdown of rocks into smaller fragments by physical or sometimes chemical processes like oxidation and carbonation as well, followed by erosion, where your disintegrated fragments or smaller fragments are now getting transported or the transport of this weathered material by agents of water, wind, glacier sometimes, or under the action of gravity. Then the movement of the sediment particles from one place to another new location will be obviously carried out by some river or some glacier, or simply it will flow under the action of gravity. It will be transported from one place to another place, and it will finally get settled and accumulated at some place, and which will also reflect some insights on the environment a sedimentary rock might have been subjected to. So, during deposition it might have been subjected to a river delta, some you can say sea beaches, some and finally also ocean floor, because the fate of your for example, some shells that we can see as you can see marine lives, be it some coral, be it some your pelecypods, be it some gastropods, which are always the hard part is dominated by calcium carbonate. That calcium carbonate that has been derived from the sea at the first place. So, after the death of the softer part, or after the death of that particular animal, what will happen? That hard part will get settled down again at the ocean floor. So, again that is also a kind of deposition you can think, but obviously it is regulated, not it is not like a simple transport from one place to another place. It is, you can say, settling of the hard part of those animals after their death under the action of gravity. They get settled on the ocean floor. They might contribute to formation of limestone. We will be talking about that as well. And finally, the lithification process, which include compaction and cementation of sediments into solid rock through or under the action of pressure and mineral precipitation. So, here is a simple example you can see of your deposition, where you have your different fragments or clasts are present, which are getting compacted during the lithification process. Finally, they are also getting cemented by the movement of water or groundwater. When moves through these grains, they precipitate other minerals within the pore spaces or within the voids or vacant spaces within this different sizes grains, or even they are of uniform grains. We will talk about that as well when we will be discussing about texture of sedimentary rock. So, it gets it might get cemented during the process of lithification. So, finally, after cementation you can refer a rock as your sedimentary rock if it is forming in a way like this. Then within weathering, I'll just like to discuss, we will have a separate set of lecture on weathering and mass wasting and different processes or even means different geomorphological processes like the transportation that we discussed about river, transportation discussed about wind and glacier. We will be dealing with that sometime else. But today here we will be looking at the two chemical ways of weathering apart from the physical breakdown. I just forgot to simply mention, I will also give you a simple example of your frost action, where your means during if there is a fracture in a rock like this, it and pre-existing fracture before the disintegration of this rock into two fragments or more fragment, then if some kind of water, be it your rainwater or groundwater, is getting accumulated within that fracture, and during your winter season it is getting freezed, then what will happen? The freezed ice will try to push the fracture away from itself, and there will be a more wider fracture that we can observe in that rock. So, after that season, again during the spring season, when the water is simply flowing out from the zone of fracture that was once occupied by ice, then this zone will look like a bigger fracture. So this is a process within weathering which can be considered as your physical weathering. But in case of chemical weathering, the chemical weathering mainly takes place under the action of water. So what happens if some rain is going on, then obviously your rainwater will pass through the atmosphere and it will have dissolved oxygen in it. Definitely it is passing through the atmosphere, so it will bear some dissolved oxygen in it, and it can react with the ferromagnesium silicate mineral that are already present in a particular igneous rock or metamorphic rock, which you can say the parent rock or the protolith of a future sedimentary rock that will be formed from the sediment derived from this igneous or metamorphic rock. So these ferromagnesium silicate minerals that are already present in this igneous or metamorphic rock, they will get subjected to oxidation process. Again, for example, you can derive a lot of iron oxide under the oxidation process, for example, formation of hematite. Similarly, another important process of chemical weathering is your carbonation, where your water will have or your water will get combined with your carbon dioxide, and finally it will form carbonic acid. Also you might have heard about your acid rain, but definitely in case of acid rain, the carbonic acid is not as much as we are talking about, or that is meant for chemical weathering. In case of acid rain, there is obviously some amount of carbon dioxide that is present along with the water, and that also forms some carbonic acid, but it is below 5% in most of the acid rain occurrences till now. So the role of this carbonic acid again is to disintegrate in a chemical way these ferromagnesium silicate minerals that are already present in an igneous rock or a metamorphic rock, and it might again result into the formation of clay minerals, which will later get again transported and deposited and lithified under or some other conditions and might form a sedimentary rock. So these are the two means you can say important processes of chemical weathering. There are other processes of chemical weathering as well. We will be dealing with that when we will discuss about weathering and mass wasting. Then comes the process after weathering and transportation by the agent of your, mainly I am not going deep into transportation, but here we can see after weathering you have the fragments, then you have the erosional agents that are wind, water, glacier. Now they are being transported from one place to another. During their movement, obviously they will move and they will transport the sediments along with it. So there is, I don't think a very detailed discussion is required on that. Then finally they are getting deposited at some low lying area or some basin area or somewhere else as well, or some you can say continental margins they are getting settled. So then your deposition starts. So your types of sediments that get deposited under the action of any agent of erosion will be classified into clastic sediments, chemical sediments which are also referred to as non-clastic one, then organic sediments. So your clastic sediments are comprised of broken fragments of pre-existing rock. Chemical sediments are formed from the precipitation of dissolved minerals. Organic sediments on the other hand are derived from remains of living organisms, like I was discussing about the hard part of your different shells that have now settled down on the ocean floor. So now if I look at the different examples, so sandstone and shale, these rocks are essentially made up of clastic sediment. Limestone, gypsum, these are essentially made up of minerals formed by or due to chemical precipitation. And also you have organic accumulation of sediments, of your organic sediments, and you can derive coal and chalk from that kind of organic sediments. Sediments may get deposited in various environment, like I was talking about already. It might get transported to some terrestrial environment like in rivers, lakes, deserts and glacier. It might also get transported to some Transitional environment, like we get to see at your sea beaches, deltaic environment, estuaries, and also finally to the marine or the ocean floor, even in the coastal areas, also it might get transported. So, like we can see, again, I would like to give a small example here, an Indian example. The sedimentation, or the sediments that are being deposited at the ocean floor in the Bay of Bengal, which is also known as the large Bengal fan. So that is nothing but the sediment that is getting derived along the course of Ganga and Brahmaputra. Finally, at the Ganga Brahmaputra delta at the Sundarbans, the whole sediment that has been carried by the Ganga river and your Brahmaputra river, they are simply pouring it onto the ocean floor in the Bay of Bengal. So that's your Bengal fan for you. An example how your sediments through rivers are getting transported and finally getting deposited on the ocean floor. Factors affecting deposition are obviously the energy of the transporting medium, that how far, or means what is the load of the sediment a river can carry. Obviously it depends on the different reaches of a river as well. When a river is, for example, flowing down the mountain, the load it can carry will differ from the load when the river is at its mature stage. So definitely there are again a few things that are related to the load a river, or you can say glacier can carry. We'll be discussing that again when we'll be discussing about your weathering, erosion and transportation. Then obviously the other parameter that is important, that is particle size, that whether the sediments are having coarse grained, or they are larger in nature, or they are fine grained or smaller in nature. So that will also control that how far a sediment might, or a particle belonging to a set of sediment will get transported from one place to another place. Again, under the action of gravity, because gravity always play a significant role, like I was referring to a river that is flowing down the slope of a mountain, will have the action of gravity will be obviously high over there when it is flowing down the slope. When you are in the mature stage of a river, when it is mostly moving or near about, it is finally pouring into the sea, at that place the gravity action will be relatively obviously less in comparison to the mountain reaches. Then the next process that gets initiated after deposition is your diagenesis and factors affecting it. So obviously your diagenesis is getting controlled. The diagenesis is nothing but the process that gets started or that generally start after deposition is complete, but before burial and lithification process, which will finally result into the formation of a rock. So diagenesis is controlled by temperature, pressure, fluids, for example groundwater that can flow within the deposited sediments, time, how long the diagenesis process is going on, composition of the sediment, and also the climate, in which climate the diagenesis is taking place. In an arid climate, or you might get evaporites, or in case of humid climate you might get some formation of kaolinite, which is a clay mineral. Processes of diagenesis also include compaction, cementation, recrystallization, replacement, dissolution, and organic processes sometimes as well. So in case of compaction, you have when the sediment is already buried, the weight of the overlying layers might causes or cause the grain to become compressed and close together. It reduces the pore spaces that are already present, so decreasing, obviously if I reduce the pore space in it, so eventually the porosity and permeability also might decrease. Cementation, if I fill up the individual pores and voids or spaces within the individual fragments, then obviously I can compact it more. So cementation is another way you can make it more compact. Finally also recrystallization can increase. Recrystallization of certain minerals can get precipitated into the void spaces or spaces that are present within the individual fragments. So these are the different diagrams that shows the processes of compaction, cementation, recrystallization. Then you can also have replacement. In some cases, minerals in the original sediment are getting replaced by new minerals. For example, aragonite shales may be dissolved and get replaced as your calcite. Then dissolution, some minerals may dissolve during diagenesis and leaving behind some pore spaces. Organic processes like bacterial activity can produce methane, which can cause carbonate materials to precipitate as well. So there is again a simple sequence where this is your initial deposition state, where your pore space or void spaces are maximum, followed by rapid burial compaction. Some of the pore spaces or void spaces are now getting filled up due to compaction. Then some early cementation, still it will not be able to complete all the pore spaces or voids, but partially it will try to take place or the interspatial spaces between the grains, individual grains. Then followed by dissolution, where your individual grain might go into some kind of solution under the action of, for example, groundwater. Then your late cementation, finally some more pore spaces or void spaces that were present even after the early cementation, they will get cemented during the later event of cementation. Finally, we will get a compacted kind of rock. You can see here under again a thin section, you have some large grains of feldspar and quartz. Then you have some chlorides that are present in between, some other rock fragments are also present. So now you have a compact rock. That is, so that is the, you can say, the process of diagenesis. Broadly, diagenesis can be grouped under 5 types. Epidiagenesis, which means refers to early diagenetic processes that occur shortly after sediment deposition and before significant burial, means it is still going on relatively at the lower depths or on the upper reaches of your earth crust. Followed by mesodiagenesis. Mesodiagenesis refers to intermediate diagenetic processes that occur during moderate burial depth and over longer geological time scale. And there is also a temperature difference between your epidiagenesis and mesodiagenesis, because here on the surface of the earth, when the diagenesis is taking place, it is approximately around 50 degrees centigrade. When you are going a little deeper with certain amount of burial of the rock or the sediments, it is not yet rock, obviously the sediments, then it will be subjected to a temperature of around 50 to 150 degrees centigrade. Followed by telodiagenesis, which refers to late stage diagenetic processes that occur during deep burial and prolonged geological history. And here the temperature might go up more than 150 till 200 degrees centigrade. Then you have also a type of diagenesis, that is taphrodiagenesis, which refers to the diagenetic processes associated if there is some tectonic activity or deformation is involved. If you are subjecting the sediments to some kind of a tectonic activity or near to an orogenic belt, we will talk about orogenic belt again in a later on some time, but somewhere where your some, you can say, some internal processes are leading to some kind of tectonic activity, like that of your volcanism, like that of earthquake. So if it is getting subjected to, the sediments are getting subjected to, for example, some earthquake at some point of time, then some diagenetic process might get initiated during its burial. So that is taphogenesis. And the last one is your hydrodiagenesis, which refers to diagenetic processes influenced by the circulation of fluids, including groundwater, meteoric water, and even sometimes hydrothermal fluids, which could get derived from some lower part of the crust, some hot hydrothermal fluids. So you can look at the different examples and detail, you can say, the mechanism, the temperature range in more detail. But if I simply concentrate on this flow chart now, so if I start with the process of deposition here, so your eogenesis or Epidiagenesis is the interaction of detrital assemblages with pore waters at shallow burial and under influence of depositional system. So, still you are in the upper part of the crust without kind of no means burial in it. Then you have some effective burial which will lead to the formation of mesogenesis, where your mechanical and chemical compaction will go on with increasing pressure temperature. Here there are other processes that will contribute to mesogenesis or mesodiagenesis is your compaction, pore water expulsion, dehydration of clays, then decarboxylation of organic matter, some petroleum generation during the due to the burial and increasing your temperature pressure condition, your growth of cements, as well as your primary cementation will take place at this stage, but later on some other later cementation will take place, and the telogenesis happens when your interaction or like we were discussing some hydrothermal fluid or some water at your shallow burial, it is interacting with the sediments, and some structural inversion might also take place due to the influence of some uplift commencing at any time of your burial or an means kind of an example. Again, if I want to put an example, kind of tectonic activity is going on like an earthquake, then also this kind of structural inversion means it result into a structural inversion. Then we will talk about the cements. There are again different types of cement, calcite cement, which are again grouped into two categories, sparite and micrite. Then you have quartz cement, clay cement, which are again effective when you are doing the primary cementation or the later cementation process. Then you have also feldspar cement and iron oxide cement. These are nothing but based on the you can say the mineralogy of the cement, these are grouped into these classes. For example, if I look at this conglomerate, there are large rock fragments that are present which are cemented by this material. Obviously, this will be cement that is actually sticking all the rock fragments together, but if I look at these individual cement in greater detail, I will see that these are nothing but these are quartz, smaller quartz grains which are kind of cementing this conglomerate rock. So, you can have also, like I was mentioning, calcite cement, two types of calcite cement based on its size also. It is differentiated as your sparite or micrite, and also some feldspar cement or iron oxide cement can be also found. If it is an iron oxide cement, the probability of getting hematite or goethite is more as your cementing material, which is again holding the rest of the rock fragments together. So, your cementation process, when the final cementation process is complete, at that time you can now say that you have been able to form a sedimentary rock. So, finally, the process of formation of the sedimentary rock is complete when the cementation is also complete. Then means after, even after the main events of diagenesis, the final event will be also a final cementation event that will complete the formation of a sedimentary rock. So, we will discuss about after this in the later parts, we will be discussing about different types of sedimentary rocks, different textures exhibited by sedimentary rocks, and also different kind of sedimentary structures. Like we have mentioned that sedimentary structures are generally of primary nature. So, we will also discuss about sedimentary structures with respect to different environments. So, I will like to end the first part of discussion on sedimentary rocks here. Thank you.